Mixtures. What are mixtures? Mixtures are substances that are made out of mixing other substances together, and it can be at least two different elements or compounds. Okay, these substances are not chemically bonded, so they're just mixed together, and you can separate them using physical processes. But first of all, let's just go through different types of mixtures. So we can have a mixture of pure elements. For example, over here we got a pure elements here of oxygen, but here we got a mixtures of pure elements of oxygen and neon. In here, in this container, we got a pure compound, which is carbon dioxide, but over here we got a mixture of compounds. We got of water and alcohol in, it is actually ethanol, so molecules of waters and ethanol. Then we can have actually mixtures that are mixtures of elements and compounds. In this container we got a molecule of water, carbon dioxide, mixed in between neon and oxygen and hydrogen, so they are all mixed together, but as you can see they are not chemically bonded together. There are no bonds in between these compounds or elements, so they are all mixtures. Okay, now we're going to be talking about the physical processes or methods that we can separate mixtures by, and this is filtration, crystallization and evaporation, simple distillation, fractional distillation, and chromatography. So, filtration. Filtration is separation of insoluble solid from liquids. So you straight away should be thinking of water and sand. You mix sand and water together and it forms a mixture, but you can easily separate it by filtering. So you have a funnel and you got a filter paper lined this funnel. You put your mixture on top and the water would collect in our conical flask, and what would left behind on the filter paper is your sand. Okay, so filtration is separation of insoluble solids from liquids. When you try to separate soluble solids from the solution, for example, you try to separate sodium chloride from sodium chloride and water mixture, which is basically a salty water, and you want to get a nice crystals of sodium chloride, which is table salt. You can use two processes, is evaporation and crystallization. Evaporation, you would put a solution in an evaporating basin or any flask, and you would heat it from underneath, so the water would evaporate or a solvent would evaporate, and what would be left behind, it would be a dry crystals. But this method can be quite abrasive, and with the heat you can actually decompose those crystals. Sometimes actually you can even burn them, and they would be quite small as well, because they didn't have much time to form nice big crystals. So often what we do, we will evaporate the liquid or solvent out, but to the point where we can see a crystals forming just on the edges of the concentrated solution. You will stop heating at that point. It would take that water basin somewhere into a dry, warm condition and would leave those crystals to develop over a long time. So the solvent would slowly evaporate over a long time. What would be left behind are nice, big, well-defined crystals. And this is the process of crystallization, when you stop evaporating, when you spot the first crystals, and then you leave the solvent to evaporate over a long period of time. Okay, now we're going to move to simple distillation, and it separates two different substances that they have different boiling points. For example, we got a mixture of water and ethanol. This is just approximate boiling points. Ethanol's got lower boiling point than water, which has got 100 degrees boiling point. So the first one that will evaporate out of the mixture will be ethanol. So ethanol vapors would rise to the top. Then they would hit a cold condenser. It's basically a tube that is being cooled down with the water from outside, like a water jacket on outside. Cold water would run outside and cool it down. So this water, ethanol vapors would turn into the liquid, and it would be collected at this end. Then when the mixture would reach 100 degrees Celsius, then the water would turn into a vapor. It would be carried upwards, it would hit the cold condenser, and would turn down into a liquid and would be taken out as a second fraction. Fractional distillation is when we are separating many parts of the mixture according to boiling points. So for example, we got here example of fractional distillation of crude oil. Crude oil is a mixture of different organic components, big, small compounds. They all mix together. We'll heat all that mixture up. Everything will turn into a vapor over here. But as you're going upwards, through the fractional distillation column, it's get cooler and cooler. So those fraction or different substances will be separated based on different boiling points. So the fractions with the higher boiling points would be condensing down on the bottom of the column, where those fractions or substances with low boiling points would be taken out as fractions at the top of fractional distillation column. Okay, now we're going to be talking about the paper chromatography. So what is a paper chromatography? It is a separation of mixtures of soluble substances based on different affinity. Affinity is likeness towards the mobile and stationary phase. So in this diagram we got a paper chromatography of food dyes. So you would put your known food coloring at the bottom of the chromatography paper. You will start in a pencil, the origin line or start line, and then with a capillary you would put your known colorings on that line, and your unknown colorings as the last. You would try to find out from what colors the unknown color is made up of. Okay, you want to find out the pure substances in that colored mixture. Right, okay, so we got a chromatography paper with a starting line and our known colors and unknown color. Now you would take a beaker and you would put a mobile phase in that. We call mobile phase a solvent because the solvent would be moving up the paper. The paper we call a stationary phase because it's not moving anywhere. So you really want to put the solvent line just under the line where you got your samples, so just to avoid any washing out of your sample. What you would notice is that the solvent is starting to move upwards across the paper, and as it's doing in that, some of the samples start to separate, some of the samples starting to travel up with the solvent, and some of them would stay at the beginning. If they stay at the beginning, that means they are having a higher affinity towards the stationary phase, so they like the paper better than the mobile phase. If they be carried upwards, they would like to stay in the mobile phase more. So as you can see, the samples would be separated based on their affinities or likeness towards the mobile and stationary phase.